The United States entered the Second World War with factories roaring, steel mills blazing, and millions of workers ready to mobilize. But none of it mattered without the one strategic asset America lacked most: ships. Troops could not sail, fuel could not move, ammunition, food, vehicles, aircraft. None could cross the oceans unless American shipyards produced cargo vessels faster than German submarines could sink them. The Atlantic had become a battlefield without smoke or gunfire, but one where tonnage meant victory and hesitation meant defeat. Henry J. Kaiser understood this reality before most military planners. He wasn't a shipbuilder, he wasn't a navy officer, he wasn't a maritime engineer. He was an outsider, a construction magnate who built roads, dams, and monumental civil projects. But he possessed the one quality American shipbuilding desperately lacked: the instinct to think in systems rather than traditions. Where naval architects saw blueprints, Kaiser saw flow, movement, rhythm. He believed the war would not be decided by who had the strongest fleet, but by who could replace what was lost faster than the enemy could remove it. His first visit to a shipyard confirmed everything. Skilled craftsmen worked with pride, but the process was painfully slow. A hull took months to assemble. Workers repeated tasks that could have been standardized. Steel waited in piles because cranes operated in fixed patterns instead of coordinated cycles. There was no malice, only habit. These men had built ships the same way for decades: sequential, manual, and cautious. But in a global conflict, tradition was a luxury America could no longer afford. Kaiser didn't criticize, he observed. He walked the yards with a notebook tucked under his arm, filling pages with arrows, circles, and rapid sketches. He watched how welders moved between tasks, how steel plates were stored, how foremen communicated, how long a crane stayed idle between lifts. He wasn't studying ships, he was studying inefficiency. And in those patterns, he recognized an opportunity almost no one else could see. What if a ship didn't need to be built from keel to deck in a straight line? What if 80% of the work could occur simultaneously? What if shipyards behaved like factories instead of workshops? This simple shift in logic would become the backbone of Kaiser's revolution. He introduced modular construction on a scale that startled naval engineers. Hull sections were fabricated in separate stations, then moved into place like pieces of industrial architecture. Deck houses were assembled with wiring and piping already installed. Prefabricated engine rooms were dropped into hulls instead of being built inside them. In traditional shipbuilding, such ideas bordered on heresy. In wartime America, they became salvation. Kaiser reorganized entire yards to support this new philosophy. Rail lines delivered steel directly to fabrication zones. Cranes operated in synchronized loops. Welders specialized in specific tasks to reduce learning curves. Foremen learned to think like managers of a production line instead of guardians of a single hull. The yards no longer built ships. They built modules that became ships. When the first hulls slid into the water in record time, skeptics claimed it was luck. When the next wave launched even faster, doubts faded. Kaiser had discovered a new American weapon: industrial speed. And speed meant survival. Workers could feel the stakes rising. Maps appeared in break rooms showing where Liberty ships were sailing. Families wrote messages on hull plates before they were welded into place. The war felt distant for many Americans, but in Kaiser's yards, it lived in every spark that fell from a welder's torch. Before we continue, if you appreciate deep, historically grounded engineering stories like this one, feel free to like and subscribe. It helps bring more of these documentaries to life. Because the question now looming over every shipyard and every Navy office was simple: if Henry Kaiser had already rewritten the rules of American shipbuilding, how much further could he push production as the war expanded across two oceans? Kaiser's early successes attracted attention across Washington, but no one yet understood how far he intended to reshape American industry. His goal wasn't merely to build ships faster, he wanted to create an industrial organism capable of sustaining a global war indefinitely. To do that, he needed to scale production beyond anything naval planners believed possible. So he built not one shipyard, but an entire network, Richmond, Vancouver, Portland, each engineered to operate with identical discipline and relentless momentum. The logic was simple. When knowledge spread instantly across every yard, innovation multiplied instead of stalling in isolated shops. If one facility discovered a faster welding sequence, all others copied it within days. If crane teams perfected a more efficient rotation pattern, every yard adjusted. This synchronization transformed Kaiser's shipyards into a unified machine stretching across the West Coast. America had never seen industrial warfare executed with such mathematical precision. At the center of this system stood the Liberty ship. The design itself was modest, almost inelegant, a simple cargo carrier built for endurance rather than beauty. But precisely because it was simple, it could be modularized aggressively. Engine rooms, decks, cabins, bulkheads, all could be prefabricated, inspected, and assembled like industrial components instead of handcrafted parts. Kaiser recognized that the Liberty ship didn't need refinement. It needed repetition. Fast, consistent, disciplined repetition. As the yards gained speed, production times dropped so rapidly that even the Navy struggled to adjust. A vessel that once required half a year could now be launched in a few weeks. Photographs circulated of hulls rising in parallel, cranes moving in choreographed patterns, welders working in waves that mimicked the tempo of an assembly line. Kaiser's workers began calling themselves soldiers of steel, fighting not with rifles, but with torches and rivet guns. And the war needed every one of them. The Battle of the Atlantic raged fiercely. German submarines hunted convoys with ruthless efficiency. Supplies vanished beneath the waves faster than they could be replaced. British cities needed food. Soviet armies needed ammunition and trucks. North Africa needed fuel. The Pacific required everything. Every lost ship stretched supply lines thinner, and every new Liberty ship restored them. Kaiser didn't simply focus on building more ships. He focused on building them more intelligently. He introduced new quality checks to reduce failure rates. He standardized processes so that inexperienced workers could become productive within weeks. He recruited women, immigrants, and workers with no maritime background, proving that skill could be taught if systems were built properly. His yards became symbols of American adaptability, places where entire communities transformed themselves into engines of war production. Yet, as output soared, challenges grew. Some Liberty ships suffered structural cracking in frigid waters, their steel fatigued by rapid temperature shifts. Critics predicted disaster. Kaiser responded with data. Metallurgists were summoned. Stress analyses were redone. Welding standards were revised. Defects were corrected without slowing the broader system. Kaiser didn't hide from problems. He treated them as design variables, solvable through engineering discipline rather than emotion. The refinement of the Liberty ship was only part of the story. As Allied operations expanded, Kaiser's yards adapted to produce tankers, escort vessels, repair ships, and even small warships. His modular philosophy allowed the same infrastructure to shift rapidly from one class of vessel to another. Traditional shipyards struggled to match this versatility. Kaiser's network absorbed change with surprising ease. Meanwhile, the human dimension of his achievements became impossible to ignore. He built medical centers to treat workers. He introduced childcare facilities, revolutionary at the time, to support the massive female workforce. He established housing communities designed around schools, transit routes, and daily necessities. Kaiser didn't just build ships, he built ecosystems that made industrial labor sustainable. By 1943, America was no longer losing the Battle of the Atlantic. Convoys strengthened, supplies stabilized. The Soviet Union received trucks, aircraft components, fuel, and food in numbers that reshaped the Eastern Front. North Africa turned into an Allied foothold. The Pacific offensive accelerated. Everywhere American logistics expanded, a Liberty ship had enabled the movement. The question that now reached Washington's highest circles was no longer whether Kaiser could meet wartime demand. It was whether his innovations could sustain the final, most demanding phase of the war. What new pressures would emerge as America prepared for amphibious landings and large-scale operations across Europe and the Pacific? By 1944, Allied strategy was shifting toward the largest amphibious operations in military history. Moving armies across oceans required not only cargo ships, but landing craft, mobile docks, repair vessels, and tank carriers capable of delivering equipment directly onto hostile shores. The US Navy faced a logistical challenge unprecedented in scale. Once again, the solution pointed back to Henry Kaiser. The Liberty ship had stabilized the supply chain, but now the war demanded something faster, more flexible, and more specialized. Kaiser responded by expanding production into categories no civilian builder had ever tackled. His shipyards began assembling attack transports, troop carriers, and support vessels using the same modular logic that had powered Liberty ship output. Each new class of ship brought unique engineering constraints, but the underlying philosophy never changed. Break complexity into solvable units, then assemble those units with relentless consistency. The Navy soon realized that Kaiser's real achievement wasn't simply speed, it was adaptability. Traditional shipyards were strong, but rigid. Kaiser's system behaved like a living organism, able to shift design priorities in weeks instead of months. When amphibious warfare intensified in the Pacific, his yards redirected resources toward landing craft and floating docks. When repairs surged after major naval battles, his facilities absorbed damaged vessels and returned them to service at astonishing rates. Warfare had become a contest of momentum, and Kaiser gave the United States a machine that refused to slow down. Yet the pressure was immense. Thousands of workers endured exhausting cycles, steel shortages fluctuated, weather disrupted schedules, political scrutiny mounted. But Kaiser's leadership remained consistent. He walked the yards daily, listening to welders, talking to crane operators, inspecting modules before they were lifted into position. He believed efficiency was not born from orders, but from mastery. When workers understood the purpose behind each step, they performed with clarity rather than fear. He also fought fiercely for worker welfare. When health problems surged from prolonged stress, Kaiser established prepaid medical care that would later evolve into the Kaiser Permanente health system. What began as wartime necessity became one of the most influential healthcare models in the United States. It was a reminder that his engineering instinct extended beyond steel and hulls. He engineered systems for people, not just machines. As the final year of the war approached, the numbers were staggering. Kaiser's yards produced more than 1,400 vessels. 1 in every 4 American ships launched during the conflict bore his influence. Convoys once strangled by U-boats now sailed confidently across the Atlantic. Amphibious landings in Italy, France, and dozens of Pacific islands were supplied and reinforced by ships built under his philosophy. Logistics no longer limited strategy. Strategy followed logistics. The moment of validation came during the liberation of Europe. The sheer volume of material required, fuel, weapons, vehicles, food, replacement parts, would have paralyzed Allied operations without the supply lines Kaiser had made possible. Generals planned invasions on the assumption that Liberty ships would arrive. Army units fought with the confidence that supplies would not fail. The war machine did not falter because its foundation was industrial, modular, and resilient. But victory carried a quieter truth. Kaiser had changed not only the war, but the nature of American industry. He proved that mass production principles could be applied far outside their original context. He demonstrated that speed could coexist with quality. He showed that innovation was not the privilege of specialists, but the result of clear systems and disciplined execution. And he confirmed that logistics, often overlooked, rarely celebrated, could shape the destiny of nations as surely as any battlefield tactic. Before we conclude, if you value deep, rigorous, engineering-driven documentaries, consider liking and subscribing. It helps bring more stories like this to the channel. As the war drew to a close and the world looked toward rebuilding, one question remained for historians and strategists alike. Had Henry J. Kaiser simply built ships, or had he created the industrial blueprint that would define American power for the rest of the century?